Anybody see the heart?
Yes.
Very nice.
Oh, it's the Antenna Nebula. It's actually two interacting galaxies. This is a shot from a telescope we have access to down in Chile, and one of my favorites. Yeah, it's a heart. And so commingling and togetherness and coming up close is a feature of the universe, a feature of astronomy, certainly, a feature of humanity. So here we are together. Let's see if I can get my slides to advance, because that's the other little tricky.
You just click on one side of it or the other.
Yeah. There we go. Okay. That was hard. We have a few announcements to go through before we get into our main program, so thanks for bearing with us. We have a very enjoyable evening ahead of us. We'll run through this agenda with the main event going in the middle. After a few announcements, I'll turn it over to Victor, who will introduce our speaker, and then we'll take a quick break and make sure all of our equipment's working. We'll come back and talk about what's going on in the club, various astronomical pursuits, including an unjournal club. We have one coming from a remote site. So I wanted to mention some of the happenings in the club. Thanks to Michael DeMario for catalyzing the formation of the AAAP Astro Imagers and for suggesting a pretty nice piece of software that we're going to give a try to, something called groups.io, which is a way of pulling an email group, just a conventional email group, but signing up by deliberate intent. You can be part of this group, and then the groups.io feature will allow us to have conversations through time and sort of keep an archival record of ideas, of images, of pictures, of software tricks, and so forth. So the concept is there's been a lot of interest in the club, a lot of advances in technology happening all around us. We're in a sea change of access to astronomy by people like us. And so we felt it really was time to create a subgroup within AAAP. No intent to exclude anybody, but please, if you're interested in joining, if you want to spend some time hands-on learning the software, learning the hardware, learning how to use your own equipment, maybe the club's equipment, get in touch with us. Send me an email is the easiest way, and I'll send that off to Michael and Jean, who have helped create the registry for this. We have about, what, 30 people have signed up? 35 have signed up for it. We're going to go with a once a month schedule, informal meetings, or maybe semi-formal in the sense that there will be an agenda in the meeting. It won't just be a free-for-all, but there will be opportunities to talk, ask questions, poll your fellows, try to learn some things, and show off your own work too. There's a lot of opportunities here. So the fourth Tuesday each month, basically the alternate Tuesday of the month from this meeting. So it'll be like bi-weekly. The regular meeting here, and then 2 weeks following this meeting. It will be by Zoom only. At least in the beginning, and we'll see how this goes. So if you don't know anything about what I'm talking about, but you're interested, feel free to send me an email. There's some descriptions in Sidereal Times over the last couple of months where we've written up what the intents are here, so you can check that out as well. So that has finally launched, a long-standing ambition of the club. And of course, being able to see what's up in the sky is part of why we are amateur astronomers, having access to the sky. I know everybody has heard about and seen pictures of the comet. This is one that I got actually a month ago. It was actually the morning of a month ago meeting that I got this data. And I'm just showing you because I think, understanding astronomy and responding to what you're seeing in the press and the media, probably your family's asking you about it. This is a chance for you to step up and be a hero in your own family. So what's up in the sky right now? Well, the comet, I don't know if you can see over here the little orange symbol. The comet has moved from several weeks ago. It was way up in the North Polar region near Polaris, and it's been coming south ever since. It has gone around the sun. It is really exiting, and it's getting fainter. But in fact, this is set up for right about now in mid-February, about 10 p.m. You could go outside on the next clear night, which actually might be Friday, is scheduled. This will be your last chance to see it because it is fading. It's about magnitude 7 now. And what's cool is it's just south of the first magnitude star Aldebaran, the primary star in Taurus, the constellation. It's moving down towards the bow of Orion the Hunter. So it's actually a good spot to try to pick it up in the night sky. Give it a shot while you have a chance. One other kind of a cool event coming up on March 1, right after sunset, look in the western sky, Jupiter and Saturn are going to be less than half a degree apart. This is a pretty phenomenal thing, not quite occulting each other. Jupiter and Venus, is that what I said? What did I say, Saturn? Jupiter and Venus. So check that out, coming up in 2 weeks. That will be a rare sighting, but only right after sunset. It'll sink below the horizon before twilight ends. And I couldn't resist tossing up this picture. I hope it looks pretty. This is one of my latest astrophotos from the Chilean operation, shot with a 24-inch plane wave scope down in the Chilean Andes. And to me, it's just astonishing to see this color contrast in a single object. So this is a emission nebula of a very unusual kind. And I can't really get into the astrophysics of what's going on, but these circular regions are shock waves where the ionized gas is being compressed. And yet you have what looks to me very much like a smoke ring coming up of that lower lens in the blue. And remember, the colors in the astrophotography world mean chemistry. There's a lot of meaning behind this that we could chat about later. But I wanted to really draw your attention to what's been happening, and hopefully your family and friends have been pestering you about your opinion of what's happening up there. This is yesterday's New York Times, and what were those flying objects? Not aliens, the White House said. They should know, right? They know all about alien technology. Well, I tell you what, there's some interesting things happening. After the balloon got shot down off the South Carolina coast, there have been 4 other events of mysterious flying objects in the sky at pretty high elevation, 30,000, 40,000, 80,000 feet. Some of them have been shot down. What's going on, guys? I think maybe this is something we should talk about after the break. What do you think is going on? And why are we so sure that these are just Chinese surveillance probes? I don't know. Something to think about. We'll come back to that. I think I've taken up enough time, and I want to turn it over to Victor.
Okay, well, we're here, and thank you, John, for stepping up to be our guest speaker. His talk is titled Cosmic Clockwork. Let me see if I can change that. Occultations, Eclipses, and Transits. Okay. Occultations, eclipses, and transits are among the most impressive solar system events we can observe. Once thought to be portents of doom or omens of the machinations of deities, these events are vivid illustrations of celestial mechanics. Our ability to predict them accurately signals the attrition of magic into rational thought. Nevertheless, they are magical events. At no other times can we get such a sense of the power associated with the movement of massive objects in our relatively near cosmic neighborhood. In particular, a total solar eclipse is an unforgettable experience as the entire landscape quickly darkens and the sun's magnificent corona appears for a short time. These events have also been of deep scientific interest on many occasions. Transits of Venus were formerly used to determine the scale of the solar system. Timings of lunar occultations helped refine long-term estimates of the gradual recession of the moon. Historical records of ancient eclipses were useful in pinning down the gradual slowing of the Earth's rotation due to tidal friction. Studies of the sun's corona enabled advancements in solar physics. Modern techniques have largely taken over in these areas, but such occasions will always remain of deep human interest. John Church, a native of Richmond, John Church graduated from the University of Virginia with a bachelor's degree in chemistry and then earned MS and PhD degrees from Lawrence University in Appleton, Wisconsin. His thesis work was concerned with the reaction of crystalline carbohydrate derivatives with oxygen under relatively mild conditions. He spent his career in research and development with American Can Company at their corporate R&D laboratory in Princeton, and then with Colgate-Palmolive at their corporate research center in Piscataway. John is the author of 16 scientific, historical, and technical publications, including several on the optics of refracting telescopes, as well as one on close conjunctions of Jupiter and Saturn. He holds 10 U.S. patents and is the author of a book chapter on the chemistry of bleach. He has written 3 books and edited several others. One of his Sky and Telescope articles traced the history of the 6¼ inch Hastings burn refractor now installed in our observatory in Washington State Park, which he and many others helped build in the late 1970s. John's been active in the club for many years, 53 to be precise. He served as assistant director, and program chair of the AAAP. His civic duties include presently serving on the West Windsor Township Zoning Board of Adjustment. He's married and has 3 children and 6 grandchildren. And once again, from me, thank you, John, for being here.
So let's start off here talking about solar system events. The moon passes in front of stars occasionally, and then even passes in front of the sun when you get a total solar eclipse if you're in the right place. And that's one of the greatest things you can ever see. I've seen 3 of them, and it's just magnificent. The moon can pass in front of planets. Planets, satellites, and asteroids can pass in front of stars, including the sun, but those are transits. Other planets can approach each other, and they do that all the time, and sometimes it's quite spectacular. And satellites can pass in front of things like lunar eclipses. Our satellite, the moon, passes in through our umbra, the shadow, and then we have that kind of eclipse. So let me go to the next slide. It didn't work, Rex. Now it should work. Okay. This is an area that I've been interested in for years, not doing it so much anymore, but lunar occultations of stars. When the moon passes in front of a star, it can be very interesting. The star can just suddenly vanish. It's striking, actually. When the dark limb of the moon passes over a bright star, the star gone. And it's instantaneous, really. So there's 2 kinds of occultations. The total occultations, where the star does not pass along the edge of the moon, but passes on the limb of the moon, and that's when it blinks out. But then you can get a grazing occultation. And we've seen one of those, where the moon just kind of skims along the star, and the mountains at the top or the bottom, north or the south of the moon, pass over the star blinks on and off and on and off several times. It's quite interesting. And those are useful for determining the profile of the moon and the shape of the mountains at the very edge of the moon. So they're rare events at any one place and very nice to see. Now, when the bright part of the moon passes over a star, that's really hard to see because the moon is so bright, it hides the star. But the best time is in spring evenings with a crescent moon up high in the sky. And if you go out there with binoculars, you might see the moon is approaching a star. And if you wait long enough in the right place, the moon will pass in front of the star will blink off and come back about an hour later. So I used to do this quite a bit back in the day, and I observed 165 total occultations and 1 graze, and we'll talk about the graze. So these were reported to the proper people who wanted to learn about those things, and they got written up. So that was okay. Good. This is working. What's the scientific uses of these occultations? For one thing, they can help you study how quickly the Earth's rotation is slowing down. The Earth's rotation gradually slows down because of tidal friction and other effects. The moon has a big effect on the Earth. It takes a long time, but there's a big effect. Everybody knows about the tides you see at the ocean. Well, these tides raise up as a hump of water, and the Earth has to rotate under this hump of water, and in so doing, there's friction against the floor of the ocean. And when it goes on long enough, age after age after age, the Earth gradually slows down its rotation. So the moon is doing this to us. We did it to the moon a long time ago. When the moon was fluid, the moon got locked in by the Earth's gravity. And that's why the same face of the moon always faces us. It goes around and it keeps facing you all the time. Eventually, billions of years from now, the Earth will get locked with the moon, and the moon will always stay up right there wherever it is, and we won't have day and night anymore. That's going to happen a long, long time from now, thank goodness. So the other thing with the occultations, they can help refine the actual orbit of the moon if it's done enough, and you get to know better of the topography in the moon's polar regions. Right now, there's a lot of interest in the moon's south pole because there's some craters there that may be very deep, and they may even hide water ice. It's quite possible, so we'll find that out in due course. Okay, now in 1973, I had a business trip to England, and it was in the north of England, but I had some extra time, so I drove down to the south of England, and I stopped at the Royal Greenwich Observatory on the south coast of England. And the reason I stopped there is because that's where they do a lot of work on lunar occultations. And I had been sending in reports for a long time, so when I went to the front desk, totally unannounced, and mentioned that I had been doing lunar occultations, they said, "Oh, welcome, welcome. That's what we do here, big time." So very, very kindly. What? Oh, you got too soon, too soon. That's the eclipse. We'll get to that. So anyway, a very nice gentleman named Leslie Morrison, who runs the occultation department there. I was totally unannounced. I came cold, and he very kindly came out and met me and took me in. He showed me this device, the occultation machine. They don't use it anymore, but this is an incredibly clever device with a rotating globe and all kinds of stuff that moves up and down. They can, with this, they could predict where an occultation was going to occur and when it would occur. No computers really, hardly anything, but they had this marvelous machine. And with this, they could give you a very good idea of where the occultation would happen. So it was a very kind visit, and totally unannounced, and they were very nice to me. So observing occultations, you don't have to go very far. If you got a scope and go out on your driveway or whatever, and if you have the right predictions, which I'll go into later, you can just sit there and watch these things happen. You don't have to go anywhere. Now, if you've got a grazing occultation where the moon is just going to skim along by the star, that's very local dependent. You have to know exactly where it's going to happen. And you can get those predictions. And in fact, we did that, and we'll get into that. And it's the best results is if you have a perpendicular line of observers with the star going like this. Now, the real pros do that. They get 5 or 10 more people, and they make a line so that some of them won't see the occultation, others will, and they get much better results that way. Well, we didn't do anything that elaborate. We didn't have the people available to do it, and we weren't set up for that. But if you do these grazes, you have to get permissions from people that you're going to put your telescope on their land. You can't just barge onto a farmer's field and put your telescopes on. They're not going to be very happy about that. And some people even put them on all abandoned railroad tracks, which is an even worse idea. A train might come. So you got to clear it ahead of time. And frequently people stop by and say, what's going on here? And you got to explain. One person in Florida who did this all the time set up in a swamp, and an alligator came and it sat there 10 feet away from it. They did the observation anyway. So this is so there was a real dedication. We didn't have any alligators when we did this. We also, you have to make an audio record of the thing. And we did that, and I have a record of that. I won't play it now, but I may post it on the website. It was really interesting what we saw. We had a great time doing that. Here's where we went. We went to the Bordentown Cemetery. And why did we do that? We did that because one of our very active members, Carl Kohler, who actually designed our observatory, happened to live not far away. And he talked to the police, and he got permission, or whatever the authorities were, for us to set up right on the corner of the observatory. So we did that, and we saw the thing, and we had a great time doing it. So this is this is just a view of what was going to happen. It's a grazing occultation of a star with a certain name. It was magnitude 5.6, which means you could barely see it without optical aid. Of course, we used optical aid. We all brought our telescopes. So this was from Bordentown, and I did make an audio track of it, and the transcription of our observations was published in a little magazine the club and others had in 1977, and also in the March 1992 Sidereal Times. Our participants were, again, Carl Kohler, who designed our observatory and engineered it. Mike Clark, who was the program chair at the time, Roxanne Tobin, who was the secretary, Tony Belkowski, and myself. So we wrote it up and reported all the timings, and they were acknowledged in their official newsletter. It was a lot of fun. So here's what it actually looks like. Here's a simulation of it. There's the star down there, and you see the dark part of the moon. Now, the star, of course, is really a point. To do it on a screen like this, they have to make it big enough for you to see. So the star is not really that size. It's a tiny little point. But this is what happens. We'll advance it here. The moon is coming along and about to knock and niche the star like that. And pretty soon, bingo, it goes behind a little mountain, and it stays there for a while. And frequently, it comes in and out several times. And we saw this happen a number of times. Then the moon comes along like this, and then finally it comes out again, and the thing is over. But it's really an interesting thing to see. They are rare at any one place. You'd be very lucky to be able to see one anywhere near here, but it does happen, and there are predictions available, and you can check that. Now we move on to the best occultation of all, a total solar eclipse. This is something. I don't know how many in this room have actually seen a total eclipse of the sun. Okay, quite a few. Thank you. And there'll be a great one coming up next year, and it'll go through Ohio, which is pretty accessible from here, and I hope that some of us can see it. So I've been fortunate enough to have seen 3 total eclipses. First one was 1970 in Virginia, and in 1972 in New Brunswick, Canada, and the 2017 one in Oregon. And we'll talk about that. Now here's what happens. As they might say, Monk would say, here's what happens. This is getting along. At this point, it was only 6 more minutes until total eclipse. The illumination of the landscape changes because the edge of the sun is more orange and red than the rest of the sun, and it gets dimmer. And so we're standing here waiting for totality. My brother Robbins is in the orange coat there. He was the one who arranged this place. And our host, Mr. Paulus, Larry Paulus, is there in the black with his ear to a phone. I'm not sure why he's on the phone when there's something great to see up in the sky. But he owned this land here, and it happened to be right on the central line of the eclipse. We were just so fortunate. My brother knew about this place, and he arranged it. The dog is not very concerned. He doesn't care about these things. But now you notice the shadows. The shadows on the ground are very sharp. They don't have much edge to them. This is because the sun has gotten to a very narrow slice, and it's almost like a point source. If you have a point source of light, it'll cast a sharp shadow. Normally, if you go outside with the sun big in the sky, the shadow won't have any sharp edges. It'll be fuzzy at the edges. But this is a very spooky and eerie effect as totality is coming on. Okay, this is what happens 10 seconds before totality. Play the video. Watch what happens.
You can play it too. Yeah.
Everybody starts shouting.
John, you can
It's not playing. It's not playing. Well, here it's playing now. Okay, and watch the landscape darken. But now we lost the sound.
That's all right.
Okay, and then it gets dark like this. And everybody's yelling and screaming. They've never seen anything like this before. It's a fantastic event. And there's the moon has covered the sun way up in the sky.
I'll play it one more time for the sound.
Thanks, that's great. This is what...
Yeah.
It's a fantastic experience. There's nothing like it. If you can see a total eclipse. Oh, yeah. You're going to play it again? Play it again, Sam. All right, here we go. There it goes. Okay, now you can see the moon's shadow up in the sky, how dark blue it is. It's rushing this way, and the landscape darkens down. There's some stranger standing out there in the field, and then it gets dark, and then there's the moon surrounded by the corona up in the sky. It's something to see. Okay, so we'll go to the next slide. Whoop. Whoop.
One more.
Okay, now this is what, I like the shape of this corona so much. I thought it looked like the face of a cat. With the 2 ears on the top and the pointed chin on the bottom, and even the fur around the face. It's like William Blake's poem about the tiger. Probably most of you know that. It struck me that's what it looked like, so I called it the cat corona. And every time you see an eclipse, the corona is differently shaped because of the sunspot cycle. The sun is very active, and the shape of the corona is always changing. So you will know pretty much in advance what the corona is bound to look like. This was kind of unpredicted. I don't think anybody predicted this exact shape for the corona, the luminous thing surrounding the sun. Now here, actually, I don't know if we'll be able to see this, but we actually saw, you could see the star Regulus to the left. I don't know if it shows up in the screen. There's a little dot there. I don't know if you can see it or not. And then way up to the right, there's Mars. There's Regulus right there. Can you see that little dot? It's a first magnitude star. Normally we could never see it in the daytime. But when you have a total eclipse, the stars and the planets come out. So that was another thing to see. Now this, my wife took this picture. This is in the middle of totality. And the landscape looks like this. And people get quiet again. They just stop the screaming because they're so impressed with what they're seeing. And that's the shadow of the moon up in the sky. Way over on the right, there's a dark streak. And that's because there were forest fires at the time. And there was smoke over there. And so that was kind of darkening the sky. That's not part of the moon's shadow. And people over there, some of them saw it and some of them didn't. The fortunate ones did see it and weren't in the smoke and they could see it. But that's the shadow of the moon overhead.
John, could you point to that one? I'm not sure everybody can see.
Oh, okay. Over here's this, there was smoke over here. And that's why there's a dark band. That has nothing to do with the eclipse itself. But the shadow of the moon is overhead, the dark blue in the sky. And if you just watch that, you'll see it slowly move as the moon moves. It's really something.
The description at that time is like it's 360 degrees of like twilight.
Yes.
Which you almost never get.
See, it's like that.
Twilight's always on one side of the sky.
Right, that goes, the bright part goes all the way around the shadow.
It's just an amazing feeling.
He was there.
I heard the hooting and hollering.
Yeah, I think I heard your voice in it.
I have a video I can play at the end.
Right. So.
Which state were you in? Sorry.
Oregon.
Oregon, yeah.
Portland, Oregon, near Portland.
Yeah, right. So we all made an expedition out there. And I was so fortunate because my brother lived not far away from this. And he knew the guy that had this space where the central part of the shadow went over. It was shot full of luck. And he got permission for us to go out there. It was fantastic. So, anyway, after the moon passes over the sun, suddenly you get the sun starting to reappear. There's a blinding flash of light and it grows. It's like a spotlight. And so again, everybody hoots and hollers. The sun is not dead, the sun has come back, and we're all happy again. It's not the end of the world, even though it looked like it. So that's a total eclipse. Now there's one coming up. You won't have to wait very long. April 8th, 2024, the path will go from Texas all the way up to Maine. It will go through Ohio, which is not that far away. Go through all these places. If you know people there or whatever, you can arrange a visit. I strongly recommend it if you can possibly make it. I didn't show the maps here because they're all copyrighted and I'm not supposed to show them, but all you have to do is go to Total Eclipse 2024 on the internet. You'll see the exact path. It goes over several cities. And the only problem is, being April, it might be cloudy and rainy. No way to know, and so you might go there and not be able to see it, but whatever. You pays your money and you takes your chance. But this will be a long eclipse, 4.5 minutes. The one that we saw was only 2 minutes. So this would be 4.5 minutes of totality, which is very long for a solar eclipse. And I hope that some of us can get to see that. If you just stay here, it'll be 90% total. It'll still be interesting. You'll see a crescent sun out there. It won't get all that dark. You might notice something. But so if you don't go anywhere, you'll still see something interesting. Now, how valuable scientifically are these things? Ancient eclipses were recorded a long time ago. People engraved their observations on clay tablets back in the Middle East, and they were able to decode these tablets, and from them they've been able to figure out how much the Earth's rotation has slowed down in this period of time, which is, again, it's continuing to do that. But from these eclipses, we now have a pretty good record of what the Earth's rotation was back in the day. Now, the refracting telescope that we have in our observatory now, which I call the HB, the Hastings-Burn refractor, was used by Hastings himself, who made the lens, at the 1883 eclipse in the middle of the Pacific Ocean, a tiny little island in the middle of the Pacific. He did spectroscopic observations of the corona. That was written up in Sky and Telescope. And some of the experts have found out that if you go to the right edge, exact edge of the eclipse, and look at these several eclipses over a period of time, you might be able to track some possible slow declines in the sun's diameter. And that was controversial. Some people said, no, that wasn't the case. Conflicting papers were published in the scientific literature. Some people said, yeah, this shows that the sun is shrinking. Other people said, no, it's not shrinking. So it was an interesting controversy for a while. Okay, here's the first eclipse that I saw. It was on the roof of a hotel near Hampton Roads, Virginia. And I took this picture a few minutes before totality. Again, you get that orange color, yellow color of the landscape. And you got the sharp tree shadows here and right down here, just because the sun is so thin at that point. Then totality came on, and I got this shot. That was March 7th, 1970. It just wasn't with any fancy equipment, just an ordinary camera with a 58 millimeter focal length lens. And that was the first corona that I've ever seen, and it has a shape that's typical for sunspot maximum. And so it's roughly symmetrical and round. It's not spread out at the equatorial regions. So some of my relatives were there. We had a great time watching this. And then I got the shot of the famous, what's called the diamond ring. When the sun reappears at the end of totality, the ring, the inner corona is still there. You can see it on the left. And then there's a spark of light at the edge. That's called the diamond ring, because you have a ring and then a bright flash of light. And the reason it looks like that with the spikes coming out is because that's the iris diaphragm of my old-fashioned telescope camera that had an iris diaphragm. So it made those little patterns. So they were able to catch that. Then 2 years later, I and my family saw a total eclipse in Dalhousie, New Brunswick, Canada. And it was high, thin clouds. It was not perfect, but at least we did see it. It was hazy, but we got a few pictures of that. And the corona is a different shape now. You see, it's at the fat part comes out the edges and not at the poles. That's because of the sunspot cycle. And then I was able to get this shot close up. It shows what they're called prominences, red eruptions at the edge of the sun. And so you normally can't see those unless you use a hydrogen alpha filter on a telescope. You won't be able to see it because the sun is so bright. But during an eclipse, if there happens to be these eruptions at the edge of the sun, you can see them. These red eruptions here. We got that. This is probably most of you have seen an eclipse of the moon. They're pretty common. And this is not really a great picture, but just for completeness, I wanted to show that. The half of the moon is in the umbra of the Earth, or where the eclipse is total, and the rest of it's not there yet. The moon moves through the Earth's shadow, and it takes a couple of hours, and you can see that happen. Probably many of you have seen this already. Now, occultations of planets by the moon. Now, this is interesting. This does happen. Usually, there's several per year in various places on the Earth. It could be all around the Earth. And in January 31st this year, not long ago, the moon occulted Mars from the southern US. And one of our members who was there made a video of it. And this is not the whole video, but it shows Mars in the process of being hidden by the moon. Mars is up in the right corner. Rich Sherman made this neat video, which we watched live while he was doing that. From New Jersey, the moon missed Mars. It didn't cover it. But from Florida, it did. So it was a really nice thing to see. The Mars gradually disappeared, because Mars isn't a star, it's a planet. It's large enough that the moon doesn't instantly cover it. So it gradually faded away over a few seconds. Very interesting to see that. Be seen. We saw a very close approach of the asteroid Eros to Kappa Geminorum, a star in Gemini, in 1975. We didn't know whether it would actually hide it or not. They did see it hide it in New England. They had several fine observations. Here, it missed by a tiny little bit called 1 arc second. And actually, we had a guy from the Princeton Packet come out and take this picture. Here's this young fellow sitting here looking through the scope we have now. And then this is Mike Clark, who was the program chair at the time. Now, this is the refractor that we have, and it's still there in our observatory in Washington Crossing State Park. We don't have the mount for it now anymore. We have a very fine updated computer-controlled mount. But the backstory on this is that in 1972, one of our members had a farm, and they had this refractor sitting at the farm, which our club had bought for the paltry sum of $200 for a 6-inch refractor a few years earlier. What a steal. It was the steal of the century. And the owner of the farm, he was selling the farm. He couldn't keep his scope there any longer. So he asked for volunteers at a meeting. I was at a meeting there, and nobody else held their hand. I said, oh, boy, I'd love to have a 6-inch refractor for the time being. So I raised my hand, and I got a crew of people to help me bring it out to my house. It weighs about 500 pounds with that cast iron pier, very heavy. And so we took the telescope off the pier. Somebody volunteered to station a wagon. They brought it out to my house. I built a little rolling dolly to put the thing on, and I had total use of the 6-inch refractor for 6 or 7 years in my garage. Fat city, man. You can't get much better. And so I would bring it out every night, and I would invite people over, and in this case, and so I had a great time. And then in 1977, our observatory started to open up after we built it, so we moved it out to the observatory. So there's quite a backstory on the scope, and it's still going strong. Now, what happens when stars get occulted by major planets? It doesn't happen very much. It's rare for stars at 6th magnitude, which is at the limit of visibility without optical aid. It's rare for stars at that brightness and brighter, but occasionally it does happen. And they can act as probes of planetary atmospheres. And I saw one. This was when Mars went over a star called Mibsuta in the constellation of Gemini in 1976. And it was visible here. Here's a simulation of it, again by the sky. And the star is obviously, you can't show a point on a computer screen very well. So they made it into a circle. But here, it was quite interesting. Mars went over this star, which was quite visible with the telescope. But this very rarely happens. And so when I was watching, the star flickered as Mars began to pass over it. The atmosphere of Mars was refracting the image of the star. And so it flickered on and off and on and off. Quite interesting to see. And that was reported later. It was written up in Sky and Telescope. Lots of people saw this, and people actually recorded it with photometric equipment. And they wrote scientific papers about it. They said, this shows such and such about the atmosphere, and it shows something else. And about 5 or 6 minutes later, Mars came out the other side of the planet like that. You very rarely will see something like this for a star of that brightness. But it was almost a unique sight. So now we get to things where they're not actual occultations or transits, but they can be close, where 2 planets, or even 3 or 4, come very close to each other. These are terrific sights. There's only one detailed record of such a thing ever happening, strangely enough, and that was in 1737 by an amateur named John Bevis at the Greenwich Observatory. And he actually saw it. The event was very low to the horizon, and the horizons weren't all that good at Greenwich, but he did see it. But that is the only detailed record we have of an actual occultation of one planet or a transit of one planet over another one. A very rare event. Now, it did happen in 1770. It was observed in China, but not here. And then I often wondered, has there ever been a situation where Jupiter passed over the planet Saturn? Two bright planets, you can see them all the time. And because they both move in the same band of the sky, called the ecliptic of the zodiac, actually, or there's a chance that Jupiter would pass over Saturn and hide it for a while. You think, well, that should happen. Why not? I mean, they're pretty big planets, and they move in roughly the same plane as seen from the Earth. Why doesn't this happen? Of course, the fact is it hasn't happened. And from the year 4000 BC to 2800 AD, it still won't happen. Kind of unexpected. I got interested in this and investigated it and actually wrote it up for a sky and telescope. It hasn't happened. It's been close, but it hasn't happened. Been several close approaches. Here's the one about Venus and Mercury that happened in the 1700s. Venus actually passed over Mercury, the little red thing, and this observer actually did see it, and he wrote it up. It's the only time this has ever been written up, anything like this. It's amazing. All this time, only this one time. Now, sometimes you get things called triple conjunctions with Jupiter and Saturn. You know, Jupiter moves around the whole sky once every 12 years, and Saturn once every 29 years. So Jupiter catches up with Saturn because Jupiter is moving faster than Saturn. And what happens when the Earth passes both of them on the inside track, as it were, you'll see, first of all, you'll see Jupiter approaching Saturn and maybe pass it. But then you get what's called retrograde motion. Because the Earth is moving faster, the planets appear to go backwards, both of them. They retrograde back. So Jupiter can pass Saturn again. And then after that, a month or so later, they both resume what's called direct motion, and they'll both go forward again. That's called a triple conjunction. It's kind of rare, but it does happen. So these are the times when maybe you get the most likely probability of Jupiter passing over Saturn. It hasn't happened. You get into a little bit of almost astrology here, because these things are so spectacular. In ancient times that people said maybe these things announce the coming of kings, maybe prophets, whatever. There's some coincidences here. This was in the second event of the triple conjunction of 1793 BC, and then the third event was here. But what happened at this time in history? You have to, before that, this is actually when Jupiter was passing Saturn, the satellites seemed to be mixed up with each other. Jupiter's satellites and Saturn's satellites got mixed in. Of course, nobody could see it. Nobody had a telescope in 1793 BC. This is what you would have seen. And then this was a close call. They almost hit. They didn't hit. Of course, not hit physically, but past each other. So this is what you would have seen. And what was happening at this time? Not to get astrological about it, but Abraham was born about this time. And Hammurabi was a great lawgiver of the Middle East back at that time. So who knows? Do these things have any I'm not an astrologer. Nobody in this room is an astrologer. Probably, but still, people wonder what these celestial signs may have influenced human events. And then what happened in 940 BC? There was another very nice conjunction. King Solomon was the big guy at that time. And maybe this in the sky showed that Solomon was one of those great kings. Who knows? I don't know. It's nice to think about things like that. It was a pretty close call there. You had the star Regulus here. You had the planet Saturn there. You had Venus up there and Jupiter up there, all not very far apart. It would have been an amazing sight with these four relatively bright things all close together. Could this have been anything? I don't know. People can speculate. And then in 26 BC, just at the time that Augustus Caesar was being crowned, these things happened again. You got Jupiter, Saturn, and Venus close to Regulus, which has been called the royal star. It's in Leo the lion. People have always imputed great powers to this particular star, Regulus. So this happened here. Yeah, see, Augustus Caesar, who knows, yeah. And then in 372 AD, you had a very nice close event. And the only people that saw it were in China, as far as we know. Nobody else ever wrote it down. It was in the dark, getting toward the dark ages, and people didn't pay much attention to it. But it did happen. And again, no occultation. And in 1226 AD, in the Morning Star, you would think somebody would have written about it then. It's not all that long ago. But again, another close pass. Nobody ever wrote anything about it. Now, this would have been a terrific event. It was off the coast of Western Australia, out in the ocean. Nobody could have seen it, but Venus passed over Jupiter. It would have done that. That's what you would have seen if you were there. And one of the rarest of all possible events. Nobody saw it. Nobody could have seen it off in the sea like that. Then you get the interesting things about triple conjunctions in the early BC, 7 BC. You got Jupiter and Saturn and Regulus all again close together. And several things happened. They were there again. There was another triple conjunction. And then in 2 BC, it was a very close approach. Some people thought, in fact, it was written up in Sky and Telescope, could this have been the Star of Bethlehem? Well, probably not, because King Herod was around at that time, and he died 2 years earlier than that. So probably not still a rather interesting event. And so this is what the close approach at 2 BC. It was below the horizon at Jerusalem, but again, a really close call there. It didn't happen, though. These things just don't happen enough. We don't see them. And now we get to transits of planets across the face of the sun. And we've been fortunate to see some of those. They're fairly common for Mercury. A few years ago, we had a party at the observatory. People saw a transit Mercury passing over the sun. And we timed it and took observations. And then in 2004, we had a terrifically rare event, a transit of Venus across the face of the sun. This hadn't happened since the 1880s. And so we were very fortunate to see it. And it was near sunrise. Now, we had a collection of people out at the Washington Crossing State Park to see this exact event. I was driving out there. I was in West Windsor Township. I was just driving past the high school there. The sun had just risen. And the sun was dim enough that it didn't hurt my eye. And there was Venus as a black dot on the sun. You could see it without any binoculars or anything. And I thought to myself, nobody has seen this. Nobody alive has ever seen this. And yet people were now seeing it. So it's quite a feeling to see that. There was another one in 2012, low in the sky in New Jersey. I'm not sure. Did anyone actually see that? You did see it. Okay, good, terrific. I missed that one. In 1970, there was a transit of Mercury over the sun, which I observed from my house. And I timed it. The people at Sky and Telescope were soliciting timings of it to send it in. So I wrote it up. I timed it. I wrote it up. And then after it appeared in Sky and Telescope, I had a telephone call from somebody in West Windsor who was a member of the Astronomy Club. And I didn't know about the Astronomy Club at all at that point. But he called me up and said, hey, I read your report with your name there in Sky and Telescope. How would you like to join AAAP? I said, I'd love to. So that's, without that transit of Mercury, I might not have been here now. So you just never know. But here's what happened in 2004 with the transit of Venus. We had a great view of that out on what's called the soccer fields at Washington Crossing State Park. But at that, the sun got just high enough above the trees where the observatory was that we could get it, we could spot it. And so we had several people come out there, and I projected the image onto a screen there. We were fortunate to have our Congressman Rush Holt, was there. And Rex knew Rush and set it up, so Rush came to see it. And he actually, Rex is now, I think, the president of the American Association for the Advancement of Science, if he still has that position. He did retire from, yeah, but he was president of AAAS for quite a while. So
Also, Don Monticello there was
yeah.
a member of AAAP, we knew very well.
Yes.
Was a research scientist at the PPL.
Yes, at PP.
That's why he knew Rush.
Right, exactly, yeah. So anyway, we were able to use the telescope to get that projected, and I even got a picture of it here. Here's Venus just coming off the edge of the sun. And we timed it and sent the timings in. These used to be of great scientific value because you could determine the scale of the solar system by timing these things. Well, they can't do that anymore, but still, we timed it and sent it in, and it got mentioned someplace. So we were fortunate indeed to be able to get this because the trees almost stopped us from seeing. We got those trees over there towards the east at the observatory. We're trying to get...
Don't get him started.
Don't get him started on that. And I remember, actually, Don came over there, and he was shaking the trees to get us to focus on the sun, and we got it, and he got it just in time, so we were able to get it. So again, you're not going to see this again for over 100 years. Nobody in this room is going to see it. I'm sorry, but you won't make it. But somebody will make it. I don't know, maybe somebody. Who knows what medical science will do.
Cryogenic.
Yeah. Okay, now there's another very fascinating field going on right now. We've heard several talks about this. These exoplanets, or planets in distant stars, going around distant stars, can pass across these stars and be detected by very fine photoelectric measurements. You see this star very slightly dim when a planet passes over the face of it. And this is being done all the time now. So they've discovered many, many exoplanets out there. They have to be very large for this to happen, to be visible. But nevertheless, it's a very active field of research now, going on all the time. Now, I would like to just show a few slides from pictures I took long ago with this telescope when I was really into photography. And I had the use of this wonderful 6-inch telescope at my house. Great to have this. I got this shot of the southern highlands of the moon with the big crater Clavius, the huge one up there, and the smaller crater Tycho here. The lighting was just right. And this was done with film. We didn't have electronics then. I don't know, how many of you have a home darkroom? Anybody? Anybody? Nobody, okay. I had a home darkroom. And I was instructed in how to do this by some friends. You have to use a special kind of film, a film called high contrast copy, which was used for making photostats. It had very high contrast and very fine grain. Well, the fine grain is fine, it's good for things like this, but the contrast is too great. We're all black and white. So you wouldn't get the fine shading. But there was something called a compensating developer, which would flatten out the curve so that you could record both the highlights and the lowlights and the shadings without losing the fine grain. So that was the thing. I had had friends who taught me how to do that, and so it works for things like this. Now, here, this is interesting. Now, this is a close-up of this crater Clavius. Over here, there's 3 mountains in a row there, and after this picture was in Sky Telescope. What is that? Oh, right, okay, right, okay. Oh, right over here. Okay, great. Oh, wow, this is fantastic. Okay, there's a row of things right in here, and I got a very interesting letter from a clever fellow who said there's a giant machine there on the moon. These are the bearings of the machine, and he sent me a sketch of it. And so he was really convinced that there's this huge, huge machine on the moon digging in the crater Clavius. Now, how huge? I'll show you how huge. Many of you have been to the Grand Canyon. I hope some of you have. Anyway, one of those bearings on the machine would have been as big as the total width of the Grand Canyon over to the north rim, which is 8 miles away. So whoever built this wonderful machine, I'm not sure I would want to meet him into big construction projects. So anyway, you get a paper published in the Sky Telescope. You never know who's going to write you a letter. You get these unbelievable things. So probably none of you have been to the Grand Canyon. If you haven't, please go. It's a wonderful sight. And now this is a close-up of the crater Tycho, one of the bright spots of the moon. And just for scale, here's West Windsor Township here, where I live. And you can even see Grover's Mill Pond here. That's where the Martians supposedly landed in 1938. And we have a monument to them in West Windsor Township by Grover's Mill Pond. Anyway, so we got quite a bit of detail here. These two bars here mark what we call 1 arcsecond of time, which is a small unit of measure. And that's about the resolving power of a 6-inch diameter lens. So we managed to capture details down to about 1 arcsecond in this picture. Now, just for comparison, there's this picture. It was taken by Orbiter 5. It's the same crater, almost the same illumination. And what I like to notice here, the shadow here of the central peak and the shadow of this little secondary peak shows up as a blip there. And if we go back, it also shows up as a little blip right there. So we got some not too bad detail here. I'm very happy with that. This is a nice telescope, and for those of you who haven't been to our observatory, please come and you can use the telescope. So we'll go on from there. This is the crater Copernicus, and I got the same evening I took the other picture. One of the best craters on the moon that you can see. It's a very fine spot. And then here's some other ones that actually I did get published in the Sky and Telescope. That's Jupiter at top with the great red spot in the middle of it with the band showing. And then I got this shot of Mars below it, and there's some nice features of Mars. So this feature is called Syrtis Major, and there's several other features. This is called a Hellas, and there's the South Polar Cap up there at the top. So again, I had a lot of help with these photographs, including my friend Bob Richardson, who actually made the print that this is copied from. He taught me a lot about astrophotography. And then finally, this is the last picture. I got Saturn here. And this was good because Saturn was then at what they call opposition. It was directly opposite the sun, so in the best position for observing. So probably many of you have seen Saturn through a telescope. The rings aren't always open like this because sometimes they're edge on, you can't see them at all, and other times they go around to the other side. So we got some details here. We got what's called Cassini's division right here. And you'll notice this is called the A ring. It's rather dark compared to the B ring, which is very bright, brighter than the actual surface of Saturn itself. And here is what's called the crepe ring, the C ring, or in front of Saturn. So again, this was rather challenging because because Saturn is faint, and I had to use a large, not that faint, but faint enough. I had to use a long focal length to make Saturn large enough to register on the film. So because at that point, the Saturn is kind of faint, so I had to use fast film, Tri-X film. Those of you who ever did film will know that Tri-X was the faster film. So I managed to get that shot. And I think that's all the shots I have and and everything I have for tonight. But if any of you want to do occultation predictions and look them up, here are the sites. You can go here and you can see when the moon is going to pass in front of a star. And all these sites will tell you that. And then, so you can see them from your own backyard. If you even have binoculars, if you got a decent one, you can see it. It's worthwhile seeing. I just like to acknowledge a lot of help here. My mentors were long ago, Bob Richardson, Dave Rayberger, and Mike Clark, the editors of Sky and Telescope, who helped me with the publications, and Leslie Morrison of the Royal Greenwich Observatory, who I visited without any prior notice and was very gracious and showed me around. Princeton Library, and Larry Paulus, who was the owner of the land where we saw the 2017 eclipse. My brother Robin's Church, who lived nearby and arranged this, and Larry Kane, who's, I don't know if Larry's online this evening. Is Larry online? You see, assistant director, whatever. He made a lot of arrangements, and I especially want to thank Ira, Rex, and Dave for helping me so much with this presentation. and getting it to actually work. Thank you, guys. Thank you, thank you, thank you. Appreciate it. And that's it. Thank you so much. And if anyone has some questions, I'll do my best to try to answer them.
John, when you're present at different total eclipses of the sun, when you're present at different total eclipses of the sun through the years,
Right.
does like the emotional feeling, does it feel the same, or has each one got its own unique feeling?
They're all unique, but it never goes away. I mean, it's just amazing. It's a truly amazing thing that happens. And as you heard on the audio track, when the sun is totally covered, everybody breaks out in these tremendous cheers. Oh boy. And then when the sun comes back, more cheering. Oh, the sun is actually coming back. So it's always a tremendous event. It used to impress the ancients who didn't know what was going on. Battles were stopped because a total eclipse of the sun happened, and many other events. It was people were so impressed, and they didn't know. They thought the sun was being eaten by a dragon, and then, we're all going to die. And then, so if you possibly can make it out to the eclipse in 2024, weather or no weather, it'd be great. It won't be that far away, and I think we'll probably work out some kind of an expedition, formally or informally, to see that. So, yes.
John, just out of curiosity, what are your personal plans for visiting a location for the eclipse of 2024?
I'm sorry, say again?
What are your personal plans?
Oh, okay, we actually have a brother-in-law who lives near Columbus, Ohio, and that's going to be right at the edge of totality, and we'll try to maybe visit him and see that. But I mean, if you're very fortunate, you'll have a relative somewhere on the path. It's going to go from Texas to Maine. It's a big eclipse. The path is pretty wide. You look on the internet, you'll see how wide the path is. You can probably find some friend somewhere that might be in the path of it. So hopefully you can. So I've got to let my brother-in-law know pretty soon that we're coming. Okay, any
I don't have a question, I have a comment.
Yes.
I find that your dedication and perseverance is very inspiring, and it has inspired me.
Thank you for saying that. Appreciate it. Anyone else? Did I explain everything that clearly that there's no questions? Yes.
I was a little confused about the retrograde with Jupiter.
Yes, I didn't explain that very clearly. Jupiter goes faster than Saturn, so it passes it. Like horses on a racetrack. You get one horse in the lead and a faster horse is behind it, it'll catch up and pass it. And then, as the Earth passes both of them, they both appear to go backwards because we're passing them. And they both go, and Jupiter will go farther back than Saturn. And then after a while, after you get far enough past that point, they both reassume what's called direct motion, west to east. The Earth is going around west to east. All the planets go around the same way around the sun, this way. And so they'll both resume what's called direct motion, and Jupiter will pass Saturn one more time. And, yeah, it goes zig, zig, zig like that. And then it won't happen again for another, for 30, however long it takes to get yet another conjunction like that. And then only some of them will be triple conjunctions. Most of them are not. Jupiter will just pass Saturn and not come back and pass it again. Yes. Well,
All right,
thank you so much for your
That was
attention.
great.
Okay, all done? All right, thank you.
Thanks again, John.
All right. Thank you, Rex. All right. Thanks
All right,
for-
guys, we're going to take a 5-minute break. We'll come back at 9:05, talk about astronomy.
For a change, right? Instead of computer glitches. Well, thanks a lot. Say, who belongs to this? Oh, right, okay, right.
Hmm.
Okay. Okay, thank you, appreciate it. Come again.
I will. Well, I ran into a King Ranger Sunday.
Oh, yeah, right, yeah, sure, yeah.
Yeah, he's still working out there. Apparently there's a lot of damage from some of the storms we've had, so they had to crash some trees and stuff.
Oh, at the park?
Yeah.
Oh, really?
Well, there was a twister that went through like a while
Oh, I
back.
know they did, yeah, I know it did, yeah.
But they, there's been some other damage, like just
Well, I don't care if all the trees fall down.
That's right, yeah.
You can see better.
Yeah, and then apparently they have occasional bear goats. You
Yeah.
see the footprints everywhere.
A bear? Oh, I'm not sure. Oh, I know there are bears over there. Sure, I know there
The
are.
population's going up, so.
Yeah, right. So it's, yeah, good. All right.
So
Oh,
be
great.
careful when you go jogging after that.
Oh, I don't do that. No.
We're starting a
All right,
summer.
thanks.
Do you have composed of members? And what we'll do is share knowledge and the learning curve of how it's done. Some people are very experienced, some are less so. So it's just a group within AAAP. And so if you're interested.
Oh, thanks. Thanks, Tom.
If you're interested.
I've never seen some of those pictures.
Oh, yeah. Yeah, yeah, oh, we had.
I know I've seen some of them.
Yeah.
I've never seen some.
Okay, right. Yeah, I wanted to.
What a huge difference from film to what we have.
Right, but if you're really into this, you can do a lot with film. Nobody does it anymore, but I don't think they probably still sell film once in a while. But
I'm still, I hate that I'm going on and off back and forth about this, but I wanted to set up, get one of my cameras running.
Yeah. You can do it.
And try to optimize it for.
Well, you'll need an adapter. Now, I have something called a T adapter. You probably know about it.
Yeah,
So you got, and to get a decent image scale on a planet, you got to extend it with a Barlow.
Right.
Okay.
Exactly.
But or
You
the,
gotta feel like it's starting around.
yeah, right. Yeah,
And the issue I'm gonna run into, and I think I've run into this before, is the optical focuser is actually to run membership. So basically, what I have to come up with something where the camera is actually inside.
Oh, right.
Right? Because when you use
Well,
a Barlow, right? Well, you know.
Yeah, you're right. Yeah, you're right. The whole thing. Yeah, it's difficult.
But I
Yeah.
want to optimize it and see if I can come up with a reliable way.
Oh, right. Yeah. I see what you're talking about. Yeah.
Whether it's a dedicated camera or not, but I want to come up with something.
Well, there are other ways you can project with an eyepiece too. So you know about that. Or you can use the direct objective without anything. Or so there's several ways to go at it. But I've always found the Barlow to be the best. The simplest.
I have a Telemate, or not the big boat, the focal extender.
Yeah.
And I actually had the adapter to go on the end that replaces the eyepiece socket with the T2 connection, so I can put the camera right on it.
Right.
And the nice thing about the television extender like that is with the 2x1 and 2-inch.
Yep.
It doesn't care where that focal is.
Right.
It could be right on top of it, or you could have an optical train this much longer behind. Doesn't even.
Yeah, you can. So
very flexible.
you try something with the moon and planets with this, because that's what the scope is good at.
Yeah.
And you get really, if you take some time, you can get some really good moon shots.
Yeah.
Especially when the moon's
What
in
would
the right
even be
place.
better for that? What do you know about meteorites? I haven't
very.
gotten to this point yet, but I need something. I want to get a monochrome camera.
Definitely not.
That way, well, you get finer, instead of having an RGB.
Right.
Right? Well, those pixels, some of those have to get thrown away, or you have to do some kind of fancy behind the scenes.
Well, I had a
software.
monochrome camera, black and white film.
Yeah, well, there you go. Fine
I'm
grain,
way
too.
ahead of you.
Fine grain.
Fine grain, high contrast copy with a compensating development.
I've been thinking about this, we have the EAA, astro imaging and stuff. And the way my approach to that is, the camera and the laptop is now my eyepiece.
Yeah,
So
right.
Much to the chagrin of a lot of the astrophotographers, I don't save pictures. I just look at it.
Just look at it.
I just look at it. I might say, like the other night, I did get Mars and the comet were less than 2 degrees apart.
2 degrees, okay.
Well, I have one of my cameras will do a 2.5 degree field of view, and I got Mars and the comet in the same shot, which is pretty neat.
Yeah.
But most of the images, I threw away. Actually, I had a lot of them. They were through my oak tree. There's one that's really artsy because there's the shadow of the branch.
Yeah, right, comment, they are,
Consistent.
that's good.
But,
Get that juxtaposition.
But,
Yeah,
it's-
yeah, I can see the problem with the Barlow, yeah.
But I'm gonna look into trying to do that. I wanna spend some more time with that.
Okay.
And see if I can get the Teleview Barlow, because that, in fact, might bring, let's see, no, it makes the focal length longer, right?
Yes.
So, actually, the focus point would come in.
Well, this is called negative projection when you use a Barlow. And you can, if you use a long extension tube, you can get tremendous magnification. That's what I had to do with Saturn.
Yeah. Well, I got a lot of.
Yeah, a lot of extension tubes, that's what you do, so.
Or you can use
So,
T2.
then I had to do what's called a hat trick. You know about the hat trick? And then, okay, because you get this thing, you can see it on the camera viewfinder or whatever, the ground glass screen or whatever. But if you open the shutter, then it shakes the tube. So what you do is you have a hat on a long stick, and you hold it up above the objective lens.
Shaking, right?
Yeah, no, you put it up there and you hide it, and then you open the shutter and let the shaking die down. Then you do deep. It's called a hat trick. Yeah, 4 seconds. It's not critical. You usually have enough latitude. So that's called a hat trick, and I was taught that. Because if you try opening the shutter, it's going, yeah, so the old hat trick, yeah.
I experimented one night and I forgot my UV IR filter, which you have to have glass lens system.
Right.
You've got to block IR doesn't focus nearly where visible light does.
Right.
Your stars get all exploded.
Yeah. You should try something like that with
But
the.
I want to try that. And then if I do get to a situation that I can find it used, monochrome cameras are very expensive, more so than the color ones. But hopefully I can find one,
Well, there's no way you can get rid of the colors, right? With the.
I thought that. But
you got to use black and white film, man.
Right. But the thing is, that pattern is still there. Those you can't interpolate
Right.
RGB
No, you
to
can't.
black and
You
white.
can't. No, that's a failing.
Yeah.
Oh, that's.
So, but that's why they.
You see, now the moon has no color. It's black and white, basically. A little bit, but not enough. That's where black and white film shines.
Yeah. Well, that's another thing that you see these guys in EAA doing, or astrophotography, and they actually do get color out of the moon, and they're not false coloring it.
Right. It is real color.
So
It's not much, but it's there.
And I've seen it sometimes with my cameras. I've been able to say there's definitely color there. It's
a little
not just
bit, right.
Gray variations.
Right. There's a little bit of color. You're right.
The first time, how many people the first time you look at the moon through the telescope with a high enough power, and you're like, oh my God, there's actually surface features there other than craters. You can see there's gradiations and shades.
Yes, absolutely.
And that just fascinating.
I know, yeah. You could spend a lifetime studying the moon. And people used to do that all the time.
Yes, they still do.
Before, they still. Who knows what's there? Maybe water.
Might be a big machine up there.
You couldn't believe this. I couldn't.
Like the same people
I wrote
say,
the guy back and I said, I'm sorry. I did my best, but I cannot see a huge. It looks like a bunch of hills. Yeah, it is incredible bearings. And he was serious.
They walk amongst us.
Yeah, I know they do. They do walk among us. This guy was serious.
Well, that's like, how many times do you get? Can we see the lunar lander on the surface of the moon?
No, not going to get that. Sorry, not going to get that. So.
I'm still trying to do Rex's. So in back of my word, Rex's challenge. I'm trying to find Shackleton crater, the South Pole.
Oh yeah, that. Yeah.
What was the other, what was that other little microphone thingy? To Rex?
The elevation of the moon and Mars. I happened to notice, hey, we're at a very favorable vibration. We should, and sure enough, we can see it. We went through the simulation. Sky safari, sure enough,
It made its way.
What did I do with it? Well, you'll need this again.
Yep.
But it's got to be
Oh, thank you. Trying to get in touch with Rich here and see if he's ready.
Yeah, I saw him online.
You know, and it's always when it's the most favorable.
Hey, Rex.
Hi.
Yeah, I've responded a couple of times in chat. I'm ready to go when you're ready.
Sorry, we're just fumbling around with our laptops here, Rich.
Yeah, I know. It's no problem. So I figured I'd just buzz in with a voice. I'm ready when you
Okay.
are. Yes, sir. Thank you.
We'll give it a go. We'll give it a go here. All right, guys, shall we pull it together here? The fun hasn't stopped yet. Okay. Hang on a second there. Pop, pop, pop. All right, hey, so we're getting the hang of this technology here. We're gonna do something a little bit different now. We're gonna have our Unjournal Club. Now remember, it's Unjournal because it's not an academic showcase. You don't have to go to some highfalutin journal, but it has to be astronomy. That's the only requirement. So this night, Rich Sherman is going to give us a little session on something he's been up to. Rich has the great pleasure of being down in the Sunshine State, which has clear skies most of the time in the winter when we don't. Rich is in Florida, and he's a member of AAAP, has been for several years, kind of splits his time between Florida and Jersey, and nobody is blaming him for being in Florida right now. So Rich, I'm going to stop sharing, and hopefully you can take over.
Okay.
Good job, Rex.
Good evening, everyone. I'm Rich Sherman, and thanks for the introduction, Rex. Talk a little bit about a challenge that I ran into doing some astrophotography, and a solution that was recommended to me that I've been very happy with. So maybe it helps other people. Maybe some other folks already know about it and use it, but I thought I'd share it. Anyway, get the Optolong filter, they say. It's this incredible new filter for nebulae, brings out incredible details. So I get the Optolong filter. And therein begins the challenge, because the filter is great, but it doesn't fit onto my 100 millimeter Skywatcher refractor. And so what am I going to do? I mean, I don't understand why this doesn't fit. My other filters fit, but this filter, for whatever reason, doesn't fit. And I end up talking to High Point Scientific, and the guys are great. At least I believe they're very helpful to me over the years. And they recommended this kind of adapter ring, which you see here for my field corrector, my field flattener, that goes on to the optical train. So I buy this this new adapter ring from the UK, and lo and behold, it doesn't fit. Again, it doesn't fit. The business end, the telescope end, doesn't screw on to the new adapter ring or the old adapter ring. So what do I going to do? I contact High Point Scientific again, and they recommend a filter wheel. And I said, well, okay. I have a one-shot color camera. I don't have a monochromatic camera. Filter wheel, it seems like a Mercedes when I'm looking for a shopping cart. And then they recommended of a filter drawer, and I had never heard of that. And I'm sure there's many people in the club that heard of it. I never heard of it. It works and replaces my 21 millimeter spacer on my optical train, and the drawer works brilliantly. It looks like this. It just slides out. There's a couple of magnets in the drawer so that it sits and stays nicely. Slides out. Lo and behold, the Optolong filter and my UV IR cut filter and other filters fit in there very nicely. I don't have a big filter wheel stuck around it since I'm shooting one shot color. It's a super, in terms of engineering terms, elegant solution. And so if you're interested in this product, it's available from a number of different vendors. Actually, it was out of stock. I got to give credit to the guys at High Point. It was out of stock, but they wanted to help me, and they looked over and they found it was available at one of their competitors. So to me, that was fairly impressive that someone business would do that, but they sent me over there. Now, this is a Gen 2 filter drawer. There's a Gen 1, which had some issues with it, of which I'm not going to get into because I don't know all the details of it, but the guy wanted to tell me all about it, and I just wanted an elegant solution and go out and take astro images. The Gen 2 version comes with about $79, as again, it just fits in your optical train as for back focus. It's a 21 millimeter spacer. You can get an extra drawer that slides in if you want to have a second or third or fourth filter that just screws right on. And then there's an additional M48, M42 adapter, which I've not had the need to use, that comes with the product. But the additional drawers you can buy for $35, and I don't have to change my weighting or my position of the scope. It's perfectly balanced, swapping out these two spacers, this one with a drawer. And so I was fortunate this week to try it out. And so as Rex mentioned, winter down here is pretty good. I went down to the Everglades and tried out the Optolong, and everyone says, you got to get the Optolong filter. Well, I got it. And after many, many months of trying to figure this out, I got IC 443, and did a bit of the Rosette Nebula with it.
Ooh,
and
nice.
it's in engineering terms very elegant. It's a spacer, it's a drawer. I don't have a big clumsy filter wheel, and at a certain stage, I'm kind of a moving to intermediate phase of astrophotography, and I think Rex and Bill and Tom and Dave are tired of answering questions. So it's kind of something that actually works without, how does this filter wheel work? And I'm having problems getting it all set up. I can figure out the mechanical piece a lot faster than the new filter wheel. So the filter drawer was a great solution for me. It's $79, and worked out pretty well. That's as sophisticated as it was. I was just so amazed at how well it worked and how easy it was compared to all the other technological challenges that I've had learning this astrophotography piece. I thought I would share it with you all. That's as simple as it is. That's all I wanted to talk about tonight. Any questions, or Rex, did you have any comments?
I have a comment. The magnets that hold I may not be able to hear you.
I can hear the magnets that hold the filter.
So, but you probably experienced this, but the magnets that actually hold the filter closed, you have to be careful when it turns upside down, because in some of them, the magnets aren't strong enough, and the filter could drop out, or if you bang it. So you got to be real careful.
For those of other views online, the comment was it's that sometimes the magnets, depending on the filter drawer you get, may not be strong enough, and so if you jostle it around, the filter can actually fall out. I'm not, and so that's a great note of warning. I don't know, maybe I don't really know all the details of what Gen 2 offers. I'll be aware of that. So far, this one has fit snugly, but I certainly will be aware of that. And if anybody else wanted to is using one, that might be something to be careful with. If the magnets aren't strong enough, you might actually lose your filter and smash it up on the ground somewhere. But this one seems pretty snug.
Do you have any examples of like a before and after photo, like a comparison?
No, it's not so much. I'm not trying to talk about the Optolong filter, but the filter drawer. So I didn't do a before and after in terms of the capabilities of the filter itself. I was just talking about my challenges in getting a simple way to get this Optolong attached to my train. So I'm sorry, I didn't do that.
That's okay. My apologies.
Yeah.
Do you have a question, So Occultations is the name of a company. I have Occultations filter that's an L Extreme. Is that what you're talking about, the L Extreme?
Yeah, Bob, the L Extreme. Yes, sir. Sorry, I wasn't more specific about that.
Any more questions? I think we're good. Thank you, Rich. That was great. And it's a really elegant solution to a difficult problem. So thank you, Rich, for sharing that.
Thanks.
Cool. Very cool. Okay.